Using graphs of equations. In this section, we're going to talk about how to read graphs, essentially, and understand what the graph is used for. Alright, so that would be word problems when you're given the graphs, and then you have to use the graph to solve the problems. So in this first one, the graph below shows the total number of apples that Emma has in her basket as related to the amount of money that she spent on the apples. Okay, so as we look at this graph, we see that the money spent on apples is on the x-axis, and the number of apples that she purchased is on the y-axis. Alright, so we want to know, on this question down here, how much money does Emma need to spend on apples in order to have a total of 70 apples. So we know we want 70 apples, so I'm going to come to the number of apples axis and go to 70, which is right here, because it looks like we're going up by tens. Alright, so that would be about right here. And then we want to find out how much money that would cost. So then we're going to come straight down, and it looks like it's about $60, because again, we're going up by tens. So she would need $60 to get 70 apples. Okay, this next example is not a linear equation, so it might be a little bit more difficult, and it's asking a different kind of question, so you'll just have to think about it as we're reading it. The graph below shows the minimum braking distance d in feet for a vehicle on dry concrete. Also, the graph d sub p is the stopping distance in poor conditions, so like rain or ice or something like that. Okay, so as we read the graph, the x-axis is our speed in our miles per hour, and our y-axis is actually our stopping distance in feet. So we want to estimate the difference, so that would be a subtraction problem, difference in stopping distance if the vehicle is moving 10 miles per hour. Okay, so 10 miles per hour, so I'm going to mark that right there. So I need to know the distance it would take in dry concrete and the distance it would take in poor conditions. So those would be the 2 points I'm concerned with right there. So it looks like in D, graph D, we're coming over to about 3. And P, D of P, we're coming over to about 7, somewhere in there. So D sub P of X would be about 7. And we want the difference. So we want to take our D sub P, because it takes longer, minus our distance, D, of a regular concrete. And it's going to be 7 minus 3. So the difference in stopping distance would be 4 feet. Make sure you label it. We've already talked about labeling things properly, so make sure you do that as well. That's it for your notes on using graphs of equations. It's not a really difficult lesson. It's just understanding what graphs look like and how to read graphs. Really, that's what it is. So go through the practice problems if you still need a little work, and then prepare for a quiz.